Welcome to Get Your FRQ On. This question is from 2013. It's question 5, and it is not calculator active. In the question stem, we are given a region R bounded between the graphs of two functions. In part A of the question, we are asked to find the area of the region R. Since this question is not calculator active, we're going to have to determine which of the two functions provided is the one above the other one for region R, which one is the upper boundary, which one is the lower boundary. So a quick analysis, if you calculate f of 1 is 0, and g of 1 is positive. Now, given the way the graphs are presented, it's obvious that g of x is above f of x for this entire interval. So the area of R can be found using the definite integral from 0 to 2 of g of x, which is 4 cosine of pi fourths x, minus f of x, which is 2x squared minus 6x plus 4, dx. Now, for non-calculator active questions that would have you actually calculate this area, this is one of the more difficult ones I've seen because of the trig. Usually if it's more complicated than this, it would be a calculator active question. I'm actually a little surprised that this isn't. Although all of these antiderivatives can be found without a calculator, these would all fall under that category of things you should be able to do by hand. So to calculate this area, I do need to find antiderivatives for this entire thing. And if I do that, the antiderivative of 4 cosine pi fourths x is 16 over pi times the sine of pi fourths x. And the antiderivative of 2x squared minus 6x plus 4 is 2/3 x cubed minus 3x squared plus 4x. Typical anti-differentiation power rule. And then I need to evaluate this between 2 and 0. If I do that, after all the arithmetic, we get 16 over pi minus 16/3 plus 12 minus 8, which eventually becomes 16 pi minus 4/3. However, anything after this equal sign, provided that it is correct, would generally be acceptable as your answer. You do not need to simplify to something like 16 over pi minus 4/3. If you have this intermediate response, that is numerically correct, and so that would typically get counted. In part B of the question, we are asked to write an integral for the volume of R when the region is rotated around the line y equals 4. So the first thing you're going to want to note is that the line y equals 4 is above both of those functions. All right, so the desired volume is going to be a volume integral minus another volume integral because we have to carve out a piece of volume from this shape. All right, so I have pi times the integral from 0 to 2 of 4, my axis of revolution, minus my function that's further away from the axis, that's our big radius function, squared minus 4 cosine of pi fourths x squared. This is our little r function. Right? So this integral would find the volume of that solid, and notice we're only asked to write the integral. We are not asked to evaluate this integral. This would be a cumbersome process to do by hand. My guess is it could be done. Like, you could spend a lot of time on this, multiplying all this stuff out, finding an antiderivative for it, and then just leaving your answer in terms of pi. But generally, they're not going to make you do something that labor intensive on the free response questions or even in a multiple choice question. Not for something this difficult. In part C of the question, again, we are asked to write an integral, not evaluate one, for the volume of the solid if square cross sections are perpendicular to the x-axis. Since we're integrating, or we have cross sections perpendicular to the x-axis, we're going to be integrating with respect to x. But because the cross sections are square, finding the area of each of those squares is relatively simple. The area of each one of those squares will just be the square of the distance between the two graphs, which is 4 cosine pi fourths x minus 2x squared minus 6x plus 4, that whole quantity squared, would give us the area of one of these square cross sections. So the desired volume would be found using the integral from 0 to 2 of a of x dx, which is the integral from 0 to 2 of 4 cosine pi fourths x minus 2x squared minus 6x plus 4 squared dx. And again, we're not supposed to evaluate this. We just need to write it. And this would be more than acceptable as a written integral for a question like this.